Okay, hello everybody again, and today we have a coding session speak about questions and answers regarding the lecture number 3. Okay, hope you see now my screen. Yes. So, thank you everyone who managed to survive this short course, and the ambition was quite huge to tell you about verification of smart contracts in just a couple of lectures. And surely this is almost impossible to become professionals in such a deep and technically advanced field during this small period of time. But anyway, I hope that was useful. And before I turn to questions and answers, let me share with you our picture from yesterday celebration of New Year holidays in Sri Lanka here. So this is really a nice place, and so if you're interested in joining our team, just write me, contact us, and we'll be happy to speak to you about this. And okay, let's switch to our topic. Regarding this little lecture, my question I have is related to the performance feasibility of this approach, because this is the real issue for most of tools which come from academia. They may work well for small toy examples, but it doesn't always imply that they could be useful in some industrial context. So that's the question. And let's see the structure of this oriented component. And the first step of the Orienta is more or less straightforward. So once you have the bytecode to build the graph is, okay, I'm not sure if it's linear procedure, but anyway, it's not, not more complex than the usual compiler does. So this is more or less straightforward step. But the second one is actually the most difficult. Um, As I told you, here we build a symbolic representation of all possible computational paths, and that would be very huge. So remember this example. So once you have just one if statement in your code, then the execution tree will consist of just two branches, each of which is just ends in one step. So this is small. Once you have two conditional statements or even 3, 4, then this grows exponentially. You might have like quite many different paths and traces here. But the worst, technically worst situation, once you have a loop here, which again quite typical situation in real industrial exams. So each loop may result in infinitely many different branching points and very long computations. So that means that even quite small piece of code can result in a very big, from the memory perspective, uh, computational tree. So this second step in this tool is probably the most resource consuming. And this is and definitely it's not complete. So each time you run it on a real code, you may realize it's like 10 minutes or 10 hours passed, and you haven't reached the final point. So you need to implement different heuristics, whether you should stop now or wait a little bit more, or terminate here, or maybe just do something else. So this is really tricky part. And another not that critical, but anyway important part is number 3, which is about, let me remind you. So once you created this symbolic representation of your computation, you check conditions whether certain bugs, certain vulnerabilities could happen with your code. And to do that, you need all these conditions specified in advance. And that's exactly the idea of this and similar tools, that the authors already spend time to formalize in all the details all the possible conditions, and then they run the tree to check whether these conditions can happen or not for this computation. And once you would like to apply this or different tool or just this approach to other situations with different bugs, different risks, different specifications, that will definitely require from you additional effort. And so this is another issue which makes this approach not really scalable. Because each time you need to extend it some new functionality, it will take you some time. So these two are really the most kind of blocking issues in terms of scalability. So this was one question. Another question was related to the list of okay. The question was quite natural. Why do I took this particular tools? And surely there are enormous number of different publications and tools and approaches. And I surely recommend you just use Google Scholar search engine, which is especially focused on research papers. So let's check. You see the link for solidity verification keyword, and you can see that the search returns almost 40,000 different publications related to this topic. And even if we restrict ourselves to the most recent, like since 2018, we see that the number is still huge. Uh, Better. So even with this filter, which shows you only the most recent publications, there are 17,000 results on solidity verification, and quite many PDF is freely available, so you don't have to pay to access the paper. And okay, let's have a short look through the topics. So okay, so for the satisfiability model theory based verification is exactly our topic. Survey is another interesting. Yes, you see. So some people work on different formalization of core solidity. So once you have this done, you can build your own tool, not from the scratch, but using the previous formalization. Another topic is model verification. That's probably people try to solve issue of scalability, events. Again, event B, it's another kind of alternative to the tree. Like I mentioned, there are different proof checkers, proof uh, provers, different tools for formal reasoning, and even B is one of the leaders. So if you don't like that tree for some reason, because it's not complete or it doesn't support certain theories, you can definitely switch to some other tools. Okay, this is also very interesting approach. CPN stands here for specific type of patronets, I assume. No, it's not here. It's probably CPN. Yes, CPN model is about patronets, and this is another nice formalization. It's similar to, so in this approach, I told you we use control flow graph, but there are different visualization of and the representations of computational models. And Patrinet is another one which is very popular, especially for concurrent programs. So definitely there is research, another paper on Solidity to Patronet's transformation. And okay, uh, business logic. Yes, this is exactly what I mentioned before. So in the example I gave you, we verify smart contract against some predefined kind of descriptions of the bug. Uh, but in most applications, you would be interested to verify it against the business logic. Then you will have to formalize this business logic, and you see there is also research and uh, research in this area. And what else? Command for machine. Okay, it looks interesting. Let me see. So this is specific for different blockchains, not only Solidity. Okay, new tools, analysis, models. Again, this collateral.net. In theory. It's another topic. Um, Most of our discussion was focused on functional verification. So we tried to check whether the smart contract fulfills some specification, either it will be related to some bugs or problems or to business logic. But another interesting direction is to verify efficiency with respect to gas performance. I hope you remember that each uh, each call to a smart contract requires you to pay some money to the system because someone have performed it. And one of the risks in your smart contracts that it can maybe okay, it's not that efficient with respect to this gas. And you see, this is another kind of direction of research. Okay, and yes, Isabel HOL, it's another alternative to the tree. Different platforms, different language. Another interesting topic, runtime verification. Uh, the idea and the tool I presented to you is supposed to be used kind of offline. So you take your code, you take your source code in Solidity, you take your bytecode, you do something, and then you uh, see the result. But another interesting approach is to do it during runtime. And surely this is a very promising research direction. And you see there are some publication in this area. And let's see one more page. Mutation testing, study, security issues, modeling, deployment. Yes, this is another approach to semantics because this is what we always need before applying formal verification. We need to formalize semantics for the virtual machine and the language. Okay, so you see there are kind of thousands of different papers, different approaches, different tools. So if you really like this topic, just spend some time looking through this collection. Okay, let's go back to okay. The last topic was test. See what we have on this test. The first question was why Ethereum is likely to suffer from attacks and vulnerabilities. So, okay, let's see possible options. Due to poor leadership, a nice answer. But surely it's too general. Due to unclear and constantly changing requirements, yes, many projects probably suffer from that. But Ethereum is community-driven project, so the procedure is not that fast and unclear because unrealistic release schedules and project deadlines because anyone can run these in other code. Definitely, this is the correct answer. This is the main issue of Ethereum that you don't have any firewalls. Everything is accessible to anyone, so anyone can do anything, call any contract and any combination of trusted and untrusted code. So that's really the main base for the attacks and vulnerabilities. Second question: formal verification is quite expensive and time consuming. Correct. Why should one use it for Ethereum? Okay. To compare actual and expected results in order to improve quality. It's more about taste because Ethereum currently runs smart contracts that manage millions of dollars. Sounds correct. To defend from malware that can steal blockchain data. Okay, steal blockchain data sounds irrelevant because blockchain is available for everyone. In order to verify multi-step transaction, that's an important part of blockchain, but it's not related to verification. So indeed, sometimes you have multi-step transactions and you need to verify it first and then put into blockchain, but this is not related to verification. This is more about mining and consensus algorithm. So the correct answer here is here. So the contracts are the algorithms that run and manage millions of dollars. So any error or any bug could result to loss of money. That's why it's really meaningful to use this technique, even if it's expensive and time consuming. Okay, what is the meaning of saying code is law? This is a very popular saying in blockchain community. And okay, let's see. We may brave human rules or laws, but we can't resist natural ones. Sounds okay, but not related to code. The law system is conservative and it doesn't want to work to get. Sounds like a slogan. Even draconian laws must be followed and enforced. This sounds reasonable. If one disagrees with the result, one must seek to change the law, like this one. And software code will one day be the final authority. Okay, definitely this is the correct answer. This is one is okay, but it's not about code is law. It's more about like code is something you must follow even if you don't like it. Yes, but code is law is saying about that once we write software, especially on blockchain, it the developer does not have authority anymore after the code is deployed. So the code is the final authority if you're speaking about blockchain. So this is the correct answer. Next. Why do you think it's important to have a variety of different data types for internet? That we discussed yesterday that this variety is source of many bugs, issues, and unclear situations. But anyway, still almost every programming language has this variety of different data types, like we have short int, signed, unsigned, etc. So save memory sounds okay. It's required by international law. Okay, but as far as I know, there are no international law which applies to design of programming language, performance, to maintain critical. No, these two are also meaningful to maintain critical legacy systems. And but if you speak about blockchain and Ethereum, Bitcoin, the systems were written from the scratch, and there was a chance uh, to have just one data type for integer, but anyway, stability still is different, so this is not correct. And improve performance or save memory. Fully it's about memory because performance, okay, may, it may somehow impact performance, but definitely it's about the memory. Okay, this is the correct answer. What is control flow graph? Structure consists of a finite set of nodes and a set of edges connecting them. It's like definition of a graph in general, so nothing about control flow. Second, a diagram that illustrates interconnections among system modules. It's a useful graph too, but again, it's more about dependencies, but not control flow. Visualize structure attributes, operations, and relationships between classes. No, that's class hierarchy, and that must be correct. Let's check the graphical representation of computation right during the execution of program. Surely this is the correct one. Okay, next question. What is symbolic computing? Okay, a field in mathematics. It uses computing capabilities to solve complex problems. Okay, it's relevant, but it's not symbolic. It's about applied computing. I assume, of course, nothing about symbolic here. Second, converting information from one symbolic system of communication into another. Okay, it's somehow related to symbolic, but it's more about translation, not computing. So this is not that far. The practice of identifying data that is no longer active and moving it out in the practice of identifying data that is no longer sounds like completely irrelevant. And the process of manipulating numbers and variables according to the rules of mathematics, definitely this is correct. So in symbolic computing, you don't actually compute the results like 2 plus 3 equals 5, but we manipulate symbols according to the rules of logic. Yes, so symbolic computing. Okay, bytecode. What is bytecode? A collection of pre-written code that users can use to optimize tasks. That's probably the definition of library. So if you're a software developer, you usually use libraries, and libraries are pre-written code, right? And you can use them to optimize the task. So it's about libraries, but not about bytecode. Any collection of code written as plain text. Okay, again, it's about code, but it's not bytecode. It's any source code. The number of bits used to represent continuous medium and highly optimized set of instructions that is executed by virtual machine, definitely yes. So bytecode is a highly optimized set of instructions that is executed by virtual machine. Okay, and last question was kind of open here. So we ask everyone just to write a short text about your impressions, your experience, your suggestions to us, because we plan to have similar course in the future, and we'll really appreciate your feedback. So you can use this form just and then submit. That's all I have for today. So thank you all again, and hope to see you. Bye.